Okay, in this video we're going through assignment number 3, our quiz prep. The quiz will be on the states of matter and phase diagrams on the next day we meet. In-person students will be in B109. There are 14 questions and it's worth 25 points. There are 6 on states of matter and 8 on phase diagrams. So section 1, states of matter. Draw what the particles of a gas vapor would look like. So we want to make sure that they're spread apart and that they're randomly throughout. You could even have them going through the container here. If you want it to, you can show movement for it also there. Now, you need to draw for the following one. Draw what a crystal would look like on the molecular level. So when we talk about molecular level, that's like what we just did with our gases. So if we're drawing a crystal, we're going to see that it is orderly and it's in a pattern. Even so, a repeating pattern for it. So I could draw another one right next to it, and with this crystal you would know what would come next because of that order we see. Now in our amorphous there would be no pattern, it's disorganized, or it lacks internal structure. So we might see one shape like this, and then we might see another shape like so, but it's not orderly with it, and you want to be able to predict what the next shape would be for it. So remember, we have our crystal lattice, that repeating piece, and then our amorphous solids like glass, plastic, or rubber that has no internal structure. So, what's one thing that you're passionate about? We talked about in class today. I would say art and teaching would be my two passions for it. Draw what the particles of a solid would look like. So if we're looking at our solid, we're going to see that our particles are close together, rigid and fixed, just meaning that they are all together for it. We wouldn't have any rogue particles on the side for it, and we would see that they're all lined up for it. Now, decide whether the following would gain or lose energy. So if we're looking at freezing, that means we're going from a liquid to a solid. And we're going to see that that's going to be losing energy because we're going from something that's more free-flowing to something that's more rigid. Evaporation, that's going from our liquid to our gas. So we're going to see that's gaining energy for it. Sublimation is our solid to our gas, skipping the liquid phase. That's going to be gaining energy for it. And then condensation is the opposite of evaporation, going from our gas to our liquid, and that's going to be losing energy for it. Okay, I think I would go for reading minds if I could turn it on and off for it. Draw what the particles of a liquid would be. So I would probably draw most of my particles on the bottom for this because they're going to be close together because of their IMF forces. It's not going to be rigid like what we saw with our solid. We might see that the particles are overlapping too for it. So now, it says, under each property write S for solid, L for liquid, or G for gas. It can have more than one. So our definite volume is not only going to be solid, but liquid too. Our indefinite shape is going to be our liquid and our gas. Our definite shape is only solid, and our indefinite volume is going to be our gas property for it. Now, section 2, phase diagrams, a graphical representation. So we have our X and we have our Y of the 3 states of matter, solid, liquid, gas, and their phase changes they undergo. So label the X going across, Y going down. We're going to see that we have our pressure here and we're going to have our temperature here. Now it says label with the states of matter. So we always have our solid, our liquid, our gas / vapor, and then we're going to see where all 3 meet is going to be my TP, my triple point, and then at the top we're going to have our CP, critical point, and everything beyond it would be our supercritical fluid for it. Now, what is the pressure of the triple point? So we would find that the triple point is at point D, and we would see the pressure, we need to go back, would be 0.5 for it. If you could be a solid, liquid, gas, which one would you be? I think I'm still going to go with gas for it, unless I could be a diamond. Now, whenever we see what is the temperature for the normal, we have to look for it at standard pressure. And we know that standard pressure is going to be at 1 atm. So what would be my normal melting point? Well, A represents solid, C is liquid, B is gas. So melting occurs between my solid and liquid, so I'm going to go over with my 1, go down, and I'm going to see that it's going to melt at 60 degrees Celsius. Okay, what phase change occurs from point A to point B? So I have my solid, I have my liquid, I have my gas. A to B is going from my gas to my liquid, so that's going to be condensation for it. If you could eat anything the rest of your life, what would it be? I think I'm going with tacos because you can get different varieties for it. What state of matter would be at 0, 0.10 and 75? So find both points and then plot it, and we would see it would be a gas at that point. So thanks for watching this pear deck review.